So we're looking at the series here of 3 to the nth divided by 5 to the n minus 1 power. We want to know if it converges or diverges, and if it converges, we want to state the sum. So you'll notice that as we look at this, we have an exponent on both the numerator and the denominator. This should kind of get us into thinking about the ratio, or not the ratio, the geometric series. And in fact, that is exactly where we're going to go. Before we do that, I do want to point out one of the nicest things of algebra is that if you have x to the a plus b, this is x to the a times x to the b. And we're going to use this as a tool today. So in particular, notice that if we have, I'll do this as 3 to the n, and then I will actually use it into our work here. If we break this up, n can be written as 1 plus n minus 1. So we can rewrite that, in which case we can rewrite 3 to the n as 3 to the first power times 3 to the n minus 1 power. So you can break up that term on the numerator into two separate pieces, and this is what's going to make our life better. All right, so we are going to start off with our sum, n is equal to 1 to infinity of 3 to the n over 5 to the n minus 1. And let's use our handy dandy tool here. We're going to write this as 3 times 3 to the n minus 1 over 5 to the n minus 1. Let's rewrite this again. Rewriting math problems is like the best thing you can do as a student. A lot of times, being able to rewrite things can allow us to see answers that we would not see otherwise. I'm going to move that 3 off to the side and into the front because it's on the numerator. We can just kind of knock it down like that. And now you'll notice both our numerator and their denominator of our fraction have the same exponent, which means we can yank that exponent out and put it up top. And now we have something that looks very much like the geometric series. So remember, in the geometric series, we've got a times r to the n minus 1, and this is going to give us a sum of a to the a divided by 1 minus r, and we need r to be less than 1 of absolute value for this to work. If you enjoy learning things like this, subscribe. All right, so our a value and our r value are the two that we have to pick out here. Our a value is equal to that 3 that we pulled out front, and our r value is 3/5. And you'll notice that if we take the absolute value of r, absolute value of 3/5, that is definitely less than 1. So it is going to converge. And now we just have to rewrite that in terms of our solution. So our summation of 3 times 3/5 to the n minus 1 and is equal to 1 to infinity is equal to, put our a up top, 1 minus our r value, 3/5. So this is 3 divided by, and I'll do the extra steps here, but you probably can do this on your own in your head, which is perfectly fine. Go ahead. So we're going to turn that 1 into a 5 divided by 5. So we have a common denominator. We can put it together. This is 3 divided by 2/5. And we are going to use here just a little bit more information here. I'm going to write this out a couple more times. And again, if you feel comfortable just going with the algebra right away, go for it. The last tool that I'll be using here is, I love this one, when you have a fraction divided by another fraction. You'll notice I changed our 3 on the top to 3 divided by 1. So you see it actually is a fraction on top, even though it doesn't look like 1, we can write it like 1. We can just flip our denominator and turn a division problem into a multiplication problem. And the reason why this is so useful is because now we end up with 3 divided 1 times 5 over 2, which can be written as 15 halves, which is a much better solution than 3 divided by 2/5. It just looks better. So knowing that just that little bit extra algebra is a really good step to help.